Today, we are changing up strings, we are attempting to reassemble corrupted strings, we are running through a maze, we are playing the lottery, and then we are validating ISBN-10 strings. Hello world, and welcome to Versus Codewars. I hope everyone is having a wonderful and safe day today. We begin our warm-up segment with a kata that calls for us to make two functions, max and min. Both functions receive a list of integers as input and return, respectively, the largest and smallest numbers in those lists. Let's go ahead and get started with this one here. We'll have two functions here. Const min equals integers. We'll pass in our integers here. And we'll have our max here, also passing in another list of integers. And what we'll go ahead and do, we can go ahead and use the array object sort method to sort these integers in such a way that the first index of the sorted arrays will be the lowest and the largest numbers in those arrays, respectively. Let's go ahead and try that here. Const sorted equals integers.sort, and in this sorting function here, we are going to return a minus b. In so doing, this sorts the integers in ascending order. And as a result, the first index of the sorted array will be the smallest number in that array. Likewise, what we'll do in our max here, we are, instead of a minus b, we are going to do b minus a. Doing this will sort the integers in descending order and cause the largest integer in the array to be sorted into the first index. Let's go ahead and punch this into Codewars to see what this looks like here. Run the tests. And we are good on that. For our next warm-up kata, we are creating a program that will take two lists of integers, a and b. We'll call them first and second in our kata solution. Each array will consist of three positive integers above 0, representing the dimensions of cuboids A and B. Again, first and second in our kata solution. The goal of this kata is to find the difference of the cuboids' volumes, regardless of which is bigger. For example, given two cuboids with dimensions 2, 2, and 3, and 5, 4, and 1, the volume of A, first, will be 12, and the volume of B, second, will be 20. Keep in mind, the volume of a cuboid is measured by multiplying the length, width, and height of the cuboid. As such, the function should return 8, because 20 minus 12 is 8. Let's go ahead and give this one a try here. Const find difference equals first and second. And what we'll do here, we're going to use the reduce method to calculate these volumes here. So const first volume equals first.reduce. We'll have our accumulator and our value here. We'll multiply that accumulator by our value in each iteration, and we'll set our initial accumulator to 1 because we're doing a multiplication here. We will do likewise the same with the second volume here. We'll do second volume. And what we'll do, we need to do our subtraction based on which of these volumes is bigger. So what we'll go ahead and do, we'll do a ternary operation here. So what we're going to do, if first volume is greater than second volume, we will return first volume minus second volume. Otherwise, we'll do second volume minus first volume. Alright, let's go ahead and punch this into Codewars to see what this looks like. Hit the test. And we are good on that. For our next warm-up kata, we are to compare each pair of integers from two arrays and return a new array with whichever integer at that index in both arrays is larger. So, given these two arrays right here, keep in mind each of these arrays will have the same dimensions, the same number of elements here. At index 0, we have 13 and 23. We have to calculate which of the two integers in the two arrays at this given index is larger. And then we'll push that larger integer into the array that will be returned here. Alright, let's go ahead and give this one a try here. Const get larger numbers. We'll again have our first and second arrays here. And what we'll go ahead and do, we'll have our result array, which will be returned here. And we'll return that result right here. Now, since both of these arrays will have the same exact number of dimensions, we should be able to do this. For let I equal 0, I is less than first.length plus I. And we shouldn't have any problems with going out of bounds. Alright, what we'll go ahead and do, result.push. We're going to go ahead and call math.max to calculate the maximum integer between the integer in the first array at this index and the integer in the second array at this index. Alright, let's go ahead and punch this one to Codewars here. This should give us an array with whichever integers at each of the given indices is larger. So, let's go ahead and punch this into Codewars and test it out here. And we are good on that. For our next warm-up kata, we are writing a dot calculator. Our goal is to write a calculator that receives strings per input. The dots will represent the number in the equation. There will be dots on one side, a mathematical operator, addition, subtraction, multiplication, and integer division, and more dots after that operator. These dots and the operator will be separated by one space. Alright, I'll call your attention to these examples right here. Here we have a string with 5 dots plus, I believe that is 15 dots right here. That should give us 20 dots right as a result. Now, these integer division operations here, we have 5 dots divided by 2 dots. 5 divided by 2 is 2 with a remainder of 1, or 2.5. Since we're doing integer division here, we're going to have to floor that quotient, and as a result, we'll have 2 dots right here. Alright, let's go ahead and give this one a shot here. Const dot calculator. We'll have our equation string right here. Alright, I'm going to go ahead and try warming up my regular expression muscles here with this one. Const equation regex. And we're going to make use of capture groups here. First, we'll have our caret and $sign to indicate the beginning and end of the string. Now we'll have, in the first capture, we'll have 3 capture groups right here. We'll have a space here. Alright, in the first capture group, we're going to look for any number of dots. And likewise for the second capture group right here. Now, or rather the third capture group here, excuse me. And now, for this center one here, we're going to want to look for any one of our mathematical operations here. So, we're going to look for any one of the following here. A plus sign, a minus sign, and a multiplication sign. We're going to look for either that or this token right here. The double, I think that's / to indicate integer division. Now, before we move on here, let's go ahead and test this out here. I'm going to grab this string and do a console.log down here. Dot calculator. We're going to paste this string right here. And what we're going to go ahead and do for now, we're going to go ahead and return the following. Equation.match. Equation regex. I might need to use exec here actually. Let's go ahead and test this out here. Node warmup.calc. Yeah, I might have the wrong method here. Equation regex. Let's try equation regex.exec and pass in our equation string here. And I believe that looks like it picks up our matches here, our capture groups here. So what we'll go ahead and try doing, let's try iterating over this here. For let I equal 0, I is less than equal, or rather, what we'll go ahead and do, constant matches equals equation regex.exec equation. And then I'm going to go ahead and try iterating over this here. For constant match of matches, we're going to go ahead and console.log our match. Let's see how well this goes here. Alright, we get our preliminary match up here, and then we get our capture group matches down here. So, what we'll go ahead and do, we'll go ahead and get our first value, which should be matches at index 1 dot length. We'll go ahead and get our second value equals matches at index 3 dot length. And then what we'll go ahead and do, we'll do a switch statement right here. And do a switch of matches at index 2. And we'll do a case plus sign. And if we run into that, we'll go ahead and return period.repeat first value plus second value. Let's go ahead and test that out of here. And we should get our 20 dots down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 dots. Now for our minus sign here, we'll return our dot repeat first value minus second value. Let's replace this with a minus sign now. And yeah, we have an invalid count value because this results in a negative number. So, alright, let's go ahead and refactor that a little bit here. Const difference equals first value minus second value. If difference is less than or equal to 0, we'll return a blank string here. And then we'll go ahead and replace this with our difference here. And we should have a blank string as a result. Alright, let's go ahead and do our multiplication operator here. And we'll return dot repeat first value times second value. Whoops, value. And then finally, our division. Case. And what we'll go ahead and do, const quotient equals math.floor, because we're doing integer division here. First value divided by second value. Of course, because we're doing division here, we need to account for divide by 0 here. If second value is equal to 0, we'll return a blank string here. And then, if quotient is equal to 0, we'll do just that as well. Otherwise, we'll do return dot dot repeat quotient. All right, let's go ahead and test that out here. Dot 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 divided by dot dot. Should get 2 dots as a result here. And we do. Let's go ahead and do 1 dot divided by 2. And we get a blank string. That's what we want. Alright, let's go ahead and punch this into Codewars to see what this looks like here. We're on the tests. And we are good on that. For our last warm-up kata of the day here, we are to write a function that returns true if a given point x, y is inside of a unit circle. A unit circle is a normal circle with a radius of 1, centered at the origin 0, 0, and returns false if that point is outside that unit circle. Let's go ahead and give this one a try here. Const point in circle. We'll have our x and our y here. Now, what I think I'll go ahead and try doing here, this sounds an awful lot like calculating the length of a vector. And to calculate the length of a vector, you take x squared plus y squared, and then you get the square root of the sum. So what we'll go ahead and do, const length, vector length equals, we'll pass in math.square root. We'll do x times x plus y times y. And this should give us the length of our point here relative to that origin point of 0, 0. So what we'll go ahead and do, we're going to go ahead and console.log first, our vector length. And we're going to go ahead and try some different values here. Console.log, point in circle. Let's try 1 and 1 here. I'm going to clear our terminal here and do node warmup unit circle. And or maybe let's try 1 and 0 then. And we do get 1 here. Alright, let's go ahead and try out some of the tests here. Let's try 0.5 and 0.5. 2 and 0. How about 0.9 and 0? Okay. Let's go ahead and give this another read of this here. The point is outside. The region bounded by the circle is considered to be an open disk, so points on the boundary of the circle should return false. So, we'll need to return true if vector length is less than 1. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Run these tests. And we are good on that. That will conclude today's warm-up segment. I will see you in the next kata. The goal of this kata is to create a function that takes a string as a parameter and does the following in the following order. Number 1, replace every letter with the letter following it in the alphabet. Number 2, make any vowels as a result capitalized. And number 3, make any consonants as a result lowercase. The alphabet should wrap around, so Z becomes A. And in this kata, Y is not considered a vowel. Let's go ahead and give this a try here. Const changer, and And we'll have our string right here. Alright, we are going to go ahead and keep a constant string that contains the letters of our alphabet. Alphabet. And we'll do our A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Alright, what we'll go ahead and do from here. We are going to split our string into its individual characters. And we're going to run that array through the reduce method. We are going to have our character. Now, what we'll go ahead and do, we're going to set our initial accumulator to a blank string. We'll have our accumulator, call it result here. Now, we'll keep a second string with our vowels here. A, E, I, O, U. Now, if our alphabet does not include our character here, we actually are going to need the index of that. Const alphabet index equals alphabet.index of our character. And if that alphabet index is -1, that means it's a different character, not in the English alphabet. So we'll just go ahead and return that character unchanged. Result plus our character here. Alright, what we'll go ahead and do, we actually need to make this a let here. We'll take our alphabet index and increment that by 1. And we will need to modulo that by the length of our alphabet string here, such that if this is a Z, this will wrap around and become an A instead. Alright, what we'll go ahead and do, we'll go ahead and calculate our new character here. Constant new char equals, or rather new letter, and we'll set that equal to our alphabet at the new alphabet index. And then, if our vowels string includes this new letter, we will go ahead and take our result and add to it the new letter to uppercase. Otherwise, we'll go ahead and take a result and just add to it the new letter. Keep in mind, our alphabet string is all lowercase letters here, so we won't have to worry about two lowercase here. And we will need to turn this into a lowercase here, by the way. Alright, and this should do it. Let's go ahead and test this out here. We'll do a console.log. Pass in our changer, pass in the string cat30. Let's go ahead and test this out here. Node change it up. And we should see the string dbu30, and we do see that. How about Alice? BMJDF, and we do see that. Alright, let's go ahead and punch this into Codewars to see what this looks like here. We will run these tests here, and we are good. Another way I could have implemented this Kata solution was through the use of regular expressions. I would have our alphabet string and vowel string as we had in our Kata solution, but instead of the reduce method that we employed, we would have used the string object's replace method, passing in a regular expression that would match each and every instance of a letter in our string one at a time, and then a matcher function that would look up that letter's index in our alphabet string and then advance that index by 1, wrapping around if necessary, and then capitalizing that replacement letter if that new letter is a vowel. Here we are given an array of strings. All of them are supposed to be the same as the original string, but unfortunately they were corrupted, which means some of the characters were replaced with asterisks. The goal of this kata is to attempt to restore the original string based on the non-corrupted characters that we have in our strings. If in some cases it is not possible to determine what the original character was, we'll use a pound sign character in the return string to indicate that we could not find the original character it was supposed to be. Alright, let's go ahead and give this one a try here. If the array is empty, we have to return an empty string. Const assemble string. We'll have our strings array here. Alright, first and foremost, if our strings array is empty, we'll return a blank string here. Alright, let's go ahead and Alright, we'll go ahead and shift the first string out here. So we'll do let initial string equals strings.unshift. Or rather, result string equals strings.unshift or shift. Yeah, we want to shift this first string out of that array. Alright, what we'll go ahead and do, we're going to go ahead and console.log that here. Actually, just go ahead and return it for now. Result string.replace any instance of an asterisk here with a pound sign. We're going to go ahead and console.log down here. We're going to go ahead and do assemble string, and we're going to go ahead and pass into it our array of corrupted strings here. Let's go ahead and feed that in a node to see what that looks like here. Node assemble string. And we have this first string here with the asterisk replaced with a pound sign. Alright. I think what we'll need to do is iterate over the we'll go ahead and iterate over these strings here for const string of strings, which should not contain that first string anymore because of the shift right here. And what we'll go ahead and do, we're going to go ahead and iterate over result string.length plus I, and then if our string, the character in the current index string at index I, is equal to an asterisk, that means we don't know what's in this particular string right here, so we'll hit continue here. Otherwise, if we'll also want to check to see if the result string at this index is not an asterisk. Alright, so if the result string at this current index is not an asterisk, or the character in our current string in our for loop here at this index is an asterisk, then we'll continue, because either we don't need to know what character of this string this is, or we don't know what character this is in this particular string. Alright, otherwise what we'll go ahead and do, yeah, if we pass this if statement right here, Yeah, I think what we'll go ahead and do our result string at index I, and we'll set that equal to string at index I here. All right, let's go ahead and punch this in a node to see what this looks like here. And that is not what we want to see here. All right, we'll go ahead and console.log that result string thus far.
Okay. Console.log the string here. And we'll go ahead and console.log the result string up here. Now, I don't think...
Let's try splitting this into its individual characters here. Instead, call this result chars. I'm going to change that up here. So chars dot join the blank string. I'm going to clear this terminal here. It's getting to be a little messy here. So chars. All right. What we should be able to do here now, result to chars at I should be set to string. Whoops. String at index I here. See what that looks like here. Yep. That is what we want to see here. Let's go ahead and get rid of these console.logs here. Alright, and let's explain for a moment what's going on here. Alright, first we have this function here, assemble string. It takes an array of strings as a parameter here. I assume each of these strings will be of the same length here. Now, if we are given an empty array here with a length of 0, we'll just go ahead and return a blank string. Alright, we have an initial array here of the characters of our first string here, and we retrieve that, and we can go ahead and make this a const here. We retrieve that by taking the first string that we were given in the array, popping it out of the beginning of the array, and then splitting that string into its individual characters here. Next, we iterate over the strings remaining in the strings array here. And for each string, we iterate over the characters of our result chars array. We check to see if we already know the character in this result chars here, this given index here, by checking to see if it's not an asterisk. And then if this is an asterisk, we then check to see if the character in the current string at the given index is an asterisk. If both of these evaluate to true, then we don't know what is in this result chars array at this index, but we do know that this char in this index is going to be the character and the string at this index here. So we take our result chars array at this given index and we set it equal to the string character at this given index here. We continue this process for each string in our given array here. Now, at the end of this for loop, we'll go ahead and take our result chars and join them back together into a string. And then we run that string through the replace method here. We check to see if there are any asterisks remaining in that final string. We take any instance of that and replace it with a pound sign. Alright, let's go ahead and try this out with some other strings here. How about this one full of asterisks here? Oops. Come on. Did I? Oh, yeah, I'm gonna go ahead and copy that. Paste that in here. Should see 6 pound signs here, and we do. How about this special case right here? Hit copy. Paste. I should see 2, 4, 6, 8, 10, 12. Yeah, 2, 4, 6, 8, 10, 12, 14, 15 pound signs here. 5. Yep. Okay, let's go ahead and punch this into Codewars to see what this looks like here. I'm going to run these tests. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see to my left here. Now, as we do in our Kata solution here, we take the first string in a given array and split it into its individual characters here. But instead of reduce or any for loops, we run that array through the map method here. And we make use of the index parameter, which is the second parameter in the map method's predicate function here. In the body of that predicate function here, we take the given array and we run it through the find method. In that predicate function, we are looking for a string where the character of that string in the index provided by the map method's predicate function is not an asterisk. If it finds such a character that and it's not an asterisk here, we will go ahead in the map method's predicate function and return that character at the index. Otherwise, we go ahead and return a pound sign here. Now, we'll take the array resulting from the map method and join that together with a blank string to get as corrected as possible the string we are looking for. Uh-oh. On the course of our adventure, we seem to have run into a very dangerous looking maze, and we have to get to the other side of that maze in order to continue. Our aim is to navigate the maze and reach the finish point without touching any of the poisonous, prickly looking walls. Doing so will kill us instantly. We will be giving a 2-dimensional array of the maze and an array of directions here. The 2-dimensional array will be the same size on both sides, length and width. Our task is to follow the directions given, and if we reach the endpoint before using up all of our moves, we'll return the string finish. If you hit any of the poisonous prickly walls we mentioned before, or go outside of the maze border, we should return the string dead. If we find ourselves still in the maze after using up all of the moves in the given directions array, we should return the string lost. The maze array will look something like this 7x7 array here. Note, as I said before, the dimensions of this maze will be the same. Now, note all of these numbers in this maze here. 0s represent safe places to walk. 1s represent those poisonous prickly walls. 2 represents our start point, and 3 represents our finish point. Now, in addition to this maze, we will receive an array of characters here, which correspond to directions that we have to go in our maze. Now, the maze array will always be square, n by n, but its size and content will alter from test to test. The start and finish positions will change for the final tests. The directions array will always be in uppercase and will be in the format of N for north, E for east, W for west, and S for south. If you reach the end point before all of your moves have gone, we return finish. If we hit any walls or go outside the maze border, return dead. If you find yourself still in the maze after using all the moves, return lost. Alright, let's go ahead and get started with this one here. Const maze runner. We'll have our maze and our directions array here. Alright, first we need to figure out where our start point is. So we'll go ahead and keep track of a position here. We'll initialize that to 0, 0 here. Alright, we need to go ahead, we'll go ahead and iterate through each of the subarrays of our maze. Let I equal 0, I is less than maze.length, plus I. And then, what we'll do is, on start index, we'll set that equal to maze at index I dot find index cell, we'll call it, and we'll look for the cell that equals 2 here, and that'll be our start point here. And then if start index is not equal to -1, we will go ahead and actually we'll go ahead and set these both to -1 here. Actually, go ahead and set this to null here and make this a let here. And then we'll go ahead and set our position to equal our a pair. The first element of that pair will be our X position, and that should be our start index. Our Y position should be the index in our for loop here. We'll start that at I right here. And we'll break out of that for loop right there. Now, I imagine if we don't have a start point, that's could be a problem. I assume the test won't look for that here. So what we'll go ahead and do, we should have our position here. And if position is still null, turn error right here. Anyway, what we'll go ahead and do, now we need to iterate now through our directions here. For const direction of directions, whoops, and we'll do a switch statement here. Switch direction, and we'll do case, and for north, case south, S for south, case east for E for east, and case W for west. And what we'll go ahead and do, if we want to go north, we'll go ahead and take our position at index 1, because that is our Y position here, and we are going to decrement that. And then for south, we'll go ahead and increment our position at index 1. And then for our east and west here, we'll do position 0 plus, whoops, plus, and position at 0 minus. Now, each time we move, we need to check our new position in the maze. So, if position Alright, first we need to check to see if our move takes us out of bounds here. So if any one of the following is true, position at 1 is less than 0, or position 1 is greater than or equal to maze.length, or position 0 is less than 0, or position 0 is greater than or equal to maze.length. If that's the case, we need to return dead. Next, we need to check to see if the cell in the maze at our current position is one of those poisonous prickly walls. So, if maze at, I think at position at 1 at position at 0 is equal to a 1. That means we touched one of those poisonous prickly walls that killed us instantly here. So we'll return dead here as well. Otherwise, if the cell at that position is a 3, that means we've reached our finish point here, and then we'll return finish. Otherwise, we will continue our little trek through this maze here. And if we reach the end of this for loop without reaching the finish line, or touching one of those poisonous prickly walls, or going out of bounds, then we kind of lose hope in escaping this maze. And at the end of this function, we'll return lost. Alright, let's go ahead and test this out here. Alright, we'll go ahead and const maze equals we'll go ahead and copy this maze over here. We'll go ahead and take this direction here. Copy const directions. Copy that over here. And let's do a console.log. Maze runner. Pass in our maze and our directions here. Alright, let's go ahead and check to see what this looks like here. Node maze runner.js. And it does return finish because we do end up reaching the end of this maze before we use up all of the moves in our directions array here. Alright, let's go ahead and try out some of these tests here. How about this one here? And copy that over here. And it gives us dead. How about 3 norths here? And that gives us lost here. Alright, I think we're ready to punch this into Codewars to see what this looks like here. But first, let's explain what's going on here. Here we have our maze runner function here, and it takes 2 parameters. Maze is a n by n 2-dimensional array consisting of the numbers 0, 1, 2, and 3. 0 represents safe spaces in the maze. 1 represents deadly walls. 2 is the start point, and 3 is the finish point. Our second parameter here is our directions array, containing each of the directions that we will be going in this maze. Can be any one of the following: N for north, S for south, E for east, and W for west. Alright, we first start by determining where we're starting out in the maze here. We gotta find the cell in the maze that is the number 2, the starting cell in the maze here. So we let our position here be null at first. We iterate through each of the subarrays in this maze right here. And for each subarray, we attempt to look for the cell in that subarray that's equal to 2 here, and we get its index here. And if we do find that start point in this particular subarray here, we will go ahead and set our position here to a tuple here. The first element being the index of the 2 that we found in this subarray, which will be our x position. And the second element being the index of the subarray that we're looking in. That'll be our Y position here. If for some reason no starting point could be found in this maze, we return error right here. Now, we will go ahead and iterate through each of the directions that we were given in the directions array here. And we modify our position based on the direction that we receive. If we receive north, we decrement our Y position here. If we receive S, we increment our Y position. If we receive E, we increment our X position here. And if we receive W, we decrement our X position here. Keep in mind, index 0 of our position pair is our X position, and index 1 of our position pair is our Y position here. Next, we check to see if, as a result of our movement, we are out of bounds here. So we check to see if the positions, either X or Y, is less than 0 or greater than or equal to the length of our maze. If it is, we are out of bounds and we return dead. Next, we check the cell in the maze at our current position here. If it's a 1, we touched a deadly wall and we return dead. Next, we check see if that cell is equal to 3. 3 represents our finish line here. If we reach that point, we return the string finish. If we reach the end of this for loop without returning any of these strings here, we return lost instead. Alright, let's go ahead and punch this into Codewars to see what this looks like here. And we are good. In this Kata solution, you saw me implement something a little extra here that you didn't see in the Kata instructions here. When looking for the starting point of our maze, I checked to see if we had actually found one here. We started our position tuple at null here, and at the end of the for loop, we checked to see if that position tuple was still null, and if it was, we returned the string error here. This is an important lesson for programmers out there. Never assume that you will always receive valid inputs in your functions here. You're gonna have some instances where you have invalid inputs here, and it's your responsibility to check each and every one of your inputs to see if they are perfectly valid. In so doing, reducing as much as possible the amount of errors and vulnerabilities in your program. Before we begin, a question. How many of you have ever played the lottery before? You ever get that thrill of purchasing the ticket and hoping that that one ticket might be the winner? Let me know, what is your best experience with playing the lottery? What's the most amount of money you've ever won from a single ticket? Let me know of your experiences in the comment section below. And that brings me to our next kata here. Given a lottery ticket represented by an array of pairs, we have to find out if we have won the jackpot here. Our lottery ticket is going to look like this example right here. Note that each pair consists of a string and a number. Each pair has both a string and a number within it. If the character code of any of the characters in the string matches that number, you get what's called a mini-win. Note that you can only have one mini-win per subarray. Once you have counted all your mini-wins, we have to compare that number to the other input provided. If your total is more than or equal to that input provided, we return the string winner. Otherwise, not a 1. We return the string loser. All the inputs will be in the correct format. Strings on tickets are not always the same length. Let's go ahead and get started with this one. Const bingo. This is what we'll call our function signature here. We'll have our ticket here, and we'll have our win here. Keep in mind, ticket is our array of pairs, and win is the number of mini-wins we have to meet or exceed to win the jackpot. Alright, let's go ahead and keep track of the number of mini-wins here. Set that equal to 0. And at the end here, we'll return if our mini-wins is greater than or equal to our win input here, we'll return winner. Otherwise, we'll return loser. Alright, what we'll go ahead and do here, we need to iterate over each of the pairs of our lottery ticket here. Const pair of ticket. Alright, we'll take our character code as the second element of our pair, and we'll check to see if one of these characters matches that character code here. Alright, what we'll go ahead and do... Now, I assume this is going to be for the lowercase a. Am I correct on that assertion here? Let's have a look at the node repo here. A.char code at... No, it's going to be the uppercase A, actually, right? Yep. Alright, with that being said, let's go ahead and get out of that here. Now, what we'll go ahead and do, we'll check to see if the string in our pair, which is going to be at index 0, includes the character code that corresponds to this character code here. So string.from char code at pair at index 1. So, if the string here... Let me go ahead actually and illustrate that a little better with a destructuring assignment here. Const string and number. And we'll set that equal to our pair. So we're going to do a destructuring assignment here. We're going to pull the string out of the pair at index 0. And we'll pull the number out of the pair at index 1. So, this becomes if string includes string.fromChar code number here. And if that is the case, we'll go ahead and increment our mini wins right here. And now once we get to the end of this for loop, again, we'll go ahead and check to see if our mini wins meets or exceeds the win input here. And we'll return winner if it does, loser if it does not. Let's go ahead and test this out here. Let's have a look at some of these tests here. I'm going to go ahead and copy this over here, console.log. Alright, and I expect to see the string winner here. I'm going to clear this terminal here, node lottery ticket, and we get the string winner as expected. How about this one right here? Oops, let's go ahead and copy this one here. I expect to see the string loser here. Yep. Okay, let's go ahead and punch this into Node to see what this looks like. Actually, I do have a little bit of an optimization in mind here. If we check to see, how about if we check to see if our mini wins meet our win parameter here. Then we'll just go ahead and return winner immediately here. Otherwise, if we reach the end of this for loop here, we return loser instead. That might be a little bit of an optimization here, so we don't have to iterate, we might not have to iterate through the entire array here. Alright, with that in mind, let's go ahead and punch this into Codewars to see what this looks like here. We're on the tests. And we are good. I don't have anything to say about this kind of solution here, so let me tell you a little bit about my own lottery experience. Where I live, one of our favorite lottery games to play is the Mega Millions, where the goal is to draw a ticket and see how many of the 5 white balls and the Mega Ball match up with the numbers that are drawn. I think the best I was ever able to get to was 3 white balls. To win the jackpot, you would have to match all 5 white balls and the Mega Ball. What kind of lotteries do you have where you live? And what is your best experience with the lottery? Do let me know of your stories in the comment section below. finally today, we are tasked with checking to see if the given string is a valid ISBN-10 identifier. ISBN-10 identifiers are 10 digits long. The first 9 characters can be any of the digits 0 through 9. The last digit can be any of the digits 0 through 9 or the capital X to indicate a value of 10. An ISBN-10 identifier is valid if the sum of those digits multiplied by their position modulo 11 equals 0. Keep in mind the modulus operation is when you're dividing one number by another and getting the remainder. Alright, here is an example right here. Here is the ISBN right here. And here are their positions right here. I'm calling your attention to this diagram in the Kata instructions here. This is a valid ISBN here because the sum of the digits in this identifier here multiplied by the positions modulo 11 is equal to 0. And here are some more examples right here. Alright, let's go ahead and get started with this one right here. First, we need to check to see if there are exactly 10 digits in this string right here. I think we can go ahead and kill 2 birds with 1 stone here and try a regular expression here. Const ISBN regex, or just call it regex here. And we'll do a regex here. We'll have our caret and our dollar sign to indicate the start and end of the string, respectively. First, we'll look for 9 digits. And then, in a non-capturing group, we'll look for either a digit or the capital X. Alright, what we'll go ahead and do, we'll go ahead and do regex.test. We'll pass in our string. If this returns false, we will go ahead and return false because we know right away this is not a valid ISBN-10 identifier here. Alright, with that done and out of the way, what we'll go ahead and do is we are going to go ahead and get the product of the sum of the products of the digits in this identifier times their position. And what we'll go ahead and do here, const product sum, we'll call it. We're going to go ahead and take the string, separate it into individual characters here. And then we're going to run that through the reduce method here. We'll have our accumulator, our value, and we also need the index of that array as well. We're going to go ahead and set the initial accumulator here because, to 0 right here. Alright, what we'll go ahead and do. First, we need to check to see. Actually, we're going to go ahead and rename this char. We're going to rename this to sum. We need to first check to see if this char is the capital X here. If char is equal to the capital X, then we will go ahead and return 10 times index plus 1. Otherwise, we will go ahead and return parse int char times index plus 1. So, as a result, we should have our product sum right here. Alright. What we finally need to do is return true if product sum modulo 11. In other words, the product sum, the remainder of the product sum divided by 11 is equal to 0. And if it is, then this string here is a valid ISBN-10 identifier, and we return true. Alright, let's go ahead and test this out here. Console.log valid ISBN-10. We're going to go ahead and pass this string in here. Oops, and we are going to go ahead and run that through our node here, and we get false, and I was not expecting that here. Okay, let's go ahead and console.log that here. Could be something wrong with our regex here. Nope, this is not our regex here. Alright, because we are actually forgetting to add that product to our sum here. I'm going to go ahead and close these in parentheses here, because the order of operations will certainly apply here. Alright, let's go ahead and try that again here. And we do get true for that. Let's go ahead and paste this invalid string here. We should get false for that. This one here, we should get false for that. Yep. How about this one here? And we get true for that here. How about this one here, which contains an X in an invalid position here? And we do get false for that. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Let's run these tests here. And we are good. Another shorter and quite possibly more optimal way to implement the regular expression that we put in place at the top of this Kata solution would be to do this. Instead of the non-capturing group that we had, looking for either the digit or capital X at the end of the string, use a character set instead, looking for the numbers 0 through 9 or the capital X. In so doing, we would save a couple of characters worth of typing, and that might be even possibly slightly more optimal way of weeding out a lot of the invalid ISBN-10 strings that would be passed in here. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a Kata author on Codewars and you would like to share your authored katas with me, feel free to drop links to those katas in the comments section below, and you might see me take on some of those katas in a future episode of Versus Codewars. I hope you have a wonderful and safe day, and I will see you on the next episode of Versus Codewars.